Let's do one more example problem. We've mentioned earlier that these are the equations that we have access to for this unit of study, and we have met 3 of the 4 so far. The first one we met was this one, and then we talked about the acceleration equation. In the last video, we ran into this equation, and in this one, we're going to use this equation right here, which I'm going to call the no time equation because it doesn't have time in it. So this is the equation to use when time is not given and we're not asked to find the time either. I think that's going to be the case here with our penguin on skis problem. The penguin moves it with an initial speed of 0.65 meters per second. When we tune in, the penguin is moving with that speed. At a later time, he has a different speed. That's v final. And during this interval, the penguin travels that far. That's d, isn't it? And we're clearly after the acceleration. We're not using the formal guess method here, but essentially you can see that that's in effect what we're doing. We're identifying the variables that we have, we're identifying the one we're looking for, and now we're going to go to our equation sheet, and you can see by the variables that we've written here on the paper that we don't have time. We're not asked about time, and we're not given the time. And so the best choice for such a case is this equation right here. V final squared is equal to V initial squared plus 2AD. V final squared is equal to V initial squared plus 2 times A times D. Let's solve this equation for A. I will go ahead and show the work. If you don't need to, that's fine, but you need to make sure you can do this correctly. I'm going to subtract VI squared from both sides, which leaves us with that. Now, to get A by itself, we're going to divide by 2 and also by D. The acceleration that we're looking for is going to be this. VF squared minus VI squared in the numerator, divided by 2, and also divided by D. So let's put the numbers in here. V final is 1.9. We checked the units when we started out. We saw meters per second, we saw meters, and that's perfect. And because of that, I'm going to be a little bit lazy and I'm not going to write the units in on this work here because we checked them to begin with. And we want to make sure we put them on our answer, but I'm not going to put them into my work here. If you want to, go right ahead. Now, when we type this into our calculator, we need to go 1.9 squared minus 0.65 squared, hit equals, and then you need to make sure that you divide by 2 and also divide by 7.3. I recommend you type this into your calculator and see if you get to 2 significant figures the same number we did, which is 0.22. And the unit for acceleration, we know now, is meters per second squared.